Hello everyone, we're Team 11 and we're going to show you, and especially you, how we can improve lean heat with our solution. Well, meet Anna. Anna owns 2 apartment buildings, each about 120 apartment units, and she sometimes gets a call from her tenants and they're complaining about being cold. And Anna has to go into this interface and, type in some numbers just to make them feel better. And she's like, why do I have to do this? Don't I have a system for this? Well, she kind of does, but we found out that it's a problem. Even after investing into Lean Heat, Danfoss customers sometimes still need to make manual changes. In addition, the tenant's quality of life and comfort is being compromised. The challenge that we see and we set ourselves to solve is how can we reduce the energy loss caused by overproduction while maintaining the tenant's satisfaction by using their behavioral data? Because we believe that the greenest energy is the one that we don't have to produce. The solution consists of the existing Lean Heat solution that we already have, well, our solution, but we are adding a reinforced learning AI. We call this subscription 11. Anna pays a monthly fee to let AI optimize the tenant's energy distribution. The basic package consists of Lean Heat and the existing solution, plus the new AI. We are also focusing, I thought I was switching the entire time, but okay. And we're focusing mostly on heating, which is something that Lean Heat is doing already right now. And now the guy in the hoodie is going to explain to you how this works.
Okay, hi, I'm the guy in the hoodie. Our solution works because we use a different kind of AI. We're going to use a behavior-based AI, which is different from the current implementation of machine learning. The difference is that our AI will use feedback directly from the tenants. What it looks like would be, for example, that when it is too cold in a room, the tenant goes and turns the valve on the radiator to increase the heat. This is a feedback that in real time is fed to the reward system of our AI, and the AI can make a real-time adjustment. Okay, what the AI is going to do with that data? The AI is going to continuously decrease the temperature in the room bit by bit, very small bits. And it is going to approach what we call a comfort threshold. The comfort threshold for us is the point right before the customer would feel uneasy about the heat in the room and would do something to change it. And the goal is to ride along that comfort threshold. This would lead to savings per day. In this graph you can see the approximate kilowatt hours saved throughout the time period of one single day. And this obviously accumulates over a year, and it saves a lot of money for Anna. Also, approximately 896 krona. This also changes the contour contract Anna has with her tenants, because that is based, the set amount the tenants pay is based on the prediction of how much energy they will use. So Anna saved in the first year money, and the tenants will in the second. So overall, we include the tenants in the loop, in the feedback loop. We reduce a lot of energy waste due to overproduction, because the AI is very specific. The electric bills are reduced. We increase the happiness of the tenants, thus also Anna's happiness, because she's not annoyed by them. And we hope that it is good enough, the savings, to incline customers to upgrade and buy an extension. And Sonja's going to talk more about that.
So in case this doesn't sound already cool enough, we also have these extensions that we want to implement later on. Extensions are used, extensions are basically used to connect additional devices to the IoT, using the same principle that we use for heating for other resources such as water, electricity, ventilation, and so on. Why more IoT? Well, our municipality does it, so we thought, why not? But basically, the case study points at the importance of using IoT, or even the effect of using just IoTs on energy savings, which is about 30%. Well, now we prepared this beautiful slide that shows benefits to all three parties involved. We believe that for Danfoss, this will be a quick and local data gathering opportunity. We think that there will be better predictions for vendors, speed and adaptability, and of course a better image because sustainability. For the building owner, we think this will bring less worries, mid-term investment opportunities, savings on maintenance costs and bills, and for the residents, we want to create a comforting home with a high quality of life, savings on bills, and of course environmental costs. This is a business presentation, so let's jump to the revenue. So, we believe to be collecting money from subscription fees, the add-on fees for additional devices that we want to connect to the network later on. We will have access to anonymized data that can be used elsewhere in the business, and then the energy production savings proven through papers.
Yes, more to that, we found a lot of papers that have a similar use case that show that if you replace the commonly used machine learning right now with reinforcement learning, which we use interchangeably as behavior-based AI, you can influence the user to cut down on energy by approximately 30%.
And that was your last comment because you used more than 6 minutes. Oops. Sorry, guys.